Alright, so let's make a graph of a log function. So we're going to make a graph of a fairly basic log function, log base 2 of x. Right? Just like with the other problems, we're going to change this to exponential form. Okay? So y equals log base 2 of x. The exponential alternative is that the base to the exponent equals x. So x is going to equal to 2 to the y. Right? So we're going to make a table of this. So x equals 2 to the y. Alright, but, so this is my formula. X equals 2 to the y. Alright, so notice that when I switched it over to exponential form, it's x equals a function of y rather than y equals a function of x. So like things are switched around. This is sort of inverses, right? So it would be hard to pick values of x and figure out what y is. So what we're going to do is switch things around, and we're going to choose values of y and figure out values of x. Right? So we're reversing things. Right? Exponentials and logs are inverses of each other. So basically, to graph the log, we reverse stuff. We pick y's and we calculate x's. Right? So we're going to pick typical y's. So 0, 1, 2, maybe 3, negative 1, negative 2, negative 3. I'm going to plug them into this equation. So x equals 2 to the 0. This gives me 1. 2 to the 1 gives me 2. 2 to the 2 equals 4. 2 to the 3 equals 8. 2 to the negative 1 equals 1/2. 2 to the negative 2 equals 1/4. And 2 to the negative 3 equals 1/8. Right? So notice this is like the table that you make for the exponential function, but your x and y values are switched around, right? Again, exponentials and logs are inverse functions. Right, so let's graph this. So I'm going to draw the x and y axes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright, so let's see what happens. So these are our coordinate points. So x is 1/8, y is negative 3. So 1/8 is really close to 0, and then y is negative 3. X is 1/4, and y is negative 2. So we're here somewhere. X is 1/2, y is negative 1. X is 1, y is 0. X is 2, y is 1. X is 4, y is 2. And x is 8, y is 3. Okay, so what we get here is a curve that looks like this. Right. As the x values increase, this is just going to keep going up slowly. Close to this y-axis, this does an asymptote. So there's a barrier here. This is not going to go past. So it's impossible to have negative values of x. No matter what y you're picking, 2 to a power is never going to give you something negative. So there's a barrier there at the y-axis, and this is called a vertical asymptote. Alright, so the graphs of a logarithmic function have a vertical asymptote, right? Basically at the place where this equal to 0. So there's a vertical asymptote at x equals 0 in this case. If this is more complicated, you just make it equal to 0 and figure out what the x value is. And it looks like a mirror image of the exponential function, right? If I graphed y equals 2 to the x, then it will look like 0, 1, 1, 2, 2, 4, 3, 8, and then half, a quarter, 1, 8. So it will look like this. Right, so this would be y equals 2 to the x, and this is x equals 2 to the y. Or, in other words, y equals log base 2 of x. All right? So you can see that these are mirror images of each other, they're inverses of each other across that line y equals x. All right? Okay, so that's the method for graphing a log function. You change it to exponential form, you pick your values of y's, and calculate your values of x's, and then you just graph the points.